Hey everyone, good morning. What did we do in the last class?
ಯಾರ ಪಾರ್ಟ್ನರ್ ಮೌಸ್ ಈ ತರ ಎಲ್ಲ ಮರ್ಚಿಟ್ಟಾರ.
Did we do? What did we discuss? So I guess I was explaining about our CNN algorithm, right? Yes. How CNN works. Okay. So if you remember, like I have explained our different steps. So today let me show you like how it works, and also we'll do the implementation of a image classification. Okay. Yeah. So we'll understand how CNN works. When it comes to how CNN works, the first thing is like we have to take an image. That's the first step, right? Take an image. So we'll take any simple image and we'll convert that into a pixel. Just a minute. Yeah. So basically, I'll be taking a simple image at corresponding pixels. Okay. Let's say, for example, this is an image. Just showing like how it's going to work with a simple example. Just assuming things and doing. So let's say this is the image. We have taken an image. Second step, what it will do? It converts into pixel. Because images are understood using a pixel. Convert image to pixel. Pixel in the sense, usually values lie within a range of 0 to 255, right? So I'm taking a very simple pixel just to show like how this entire process is going to work. Okay. So that calculations becomes easy and even you should understand it, like how it works. So this is basically an image. Taking an image, converting an image to a pixel. Then, so what next? Once you convert an image to a pixel, so you can see the order of pixel is basically 6 cross 6, right? The next important step is like we need to apply the convolution. We need to apply convolution. So what do you mean by convolution? Already discussed. It's a mathematical function where one function revolves around another function to generate a new function. So I've already taken a pixel, another function I have to take a filter. Right? I'll take a simple filter, which is 3 cross 3 filter. Let's say this is your filter. According to convolution, this filter, which is of order 3 cross 3, this is a pixel. So now filter has to revolve around this pixel to generate a new function, which we call it like a convolved map. Okay. So let me show you like how it's going to work. When I say a convolution, it just performs element-wise matrix multiplication between a pixel and filter. When I say convolution, element-wise matrix multiplication will happen between pixel and filter. Will happen between pixel and filter. Okay. See how it works. Simple. First step, this filter is going to revolve around this particular pixel. Like how it revolves. So it takes this particular section of a pixel. So now the matrix multiplication should be performed between these two matrices. 0, 0, 0, 0, 0, 0. A normal element to element matrix multiplication. Okay. And your filter is 1, 0, minus 1, 2, 0, minus 2, 1, 0, minus 1. So what happens to your matrix? What happens to your matrix? Told you that 0 multiplied anything will always be 0. You will get 0, 0, 0, 0, 0, 0. And if you sum all these elements, you will get a 0. That's your first element, you got it. Done. Okay, next. Then in our second round, it will take a second matrix. Getting? So what happens now? So it is 0, 0, 0, 0, 0, 1, 1, 1. Multiply with your filter. 1, 0, minus 1, 2, 0, minus 2, 1, 0, minus 1. First row, first column, first column, everything will be 0. Second column, again it will be 0. In a third column, you will get it like minus 1, minus 2, minus 1. So if you sum all the elements, you're gonna get minus 4. So next element is minus 4, like this. Okay. Now move one step ahead. What will happen? So again, so it is 0, 0, 1, 1, 1, 1, 1, 1. Multiply with 1, 2, 1, 0, 0, minus 1, minus 2, minus 1. So first column 0, second column 0, only third column will be left. Again, that is also minus 1, minus 2, minus 1. So it's going to be minus 4. It's going to be minus 4. Cleared? Understood? So now, what will happen to the next round? So first one, second one, third, fourth. Fourth is this. Like this. Every time it is moving one step forward. Getting? So now the matrix will be like 1, 1, 1, 1, 1, 1. Multiply it 1, 0, minus 1, 2, 0, minus 2, 1, 0, minus 1. So if you multiply, first column will be 1 to 1, second column will be 0, third column will be minus 1, minus 2, minus 1. If you sum everything, you will get a 0. So this is how you got a matrix. Hope it's clear. This is for one stride. Same concept is going to work with the next. Now you have to move down, one step down. It will take this 0, 0 matrix. You will get 0. Then 0, 0, 1 matrix. So you'll get minus 4. Same process you have to repeat. If you take this, it will become minus 4. If you take final 1, 1, 1 matrix, so it will be 0. Okay, that is a second step. Now it will move one step downward. So it will be this. Again, it will be 0. This, it will be minus 4. This, it will be minus 4. Finally, this, which is going to be 0. And then this is 0. This is -4. This will be -4, and finally 1, 1, 1. So it will be 0. We call this particular matrix as a feature map or convolved map. The result that we got after applying a convolution, we know the process of convolution is all about extracting features from an image. That's what your convolution is doing. I hope you understood. I showed with a simple pixel, usually pixels will be like very high. It takes time to do all those stuff. Imagine this is for one image, like that, there would be thousands of images, right? Clear? Understood? Any questions? So this is how the convolution process is going to work. Now, well, we applied a convolution. We got a matrix something like this. So what is the next layer after convolution? So after convolution, the next step is like we have to apply a pooling layer. Apply pooling. We know pooling is basically used to extract the important features. Used to extract important features. Used to extract important features from convolved map. Just now, whatever we got the whatever matrix we got upon convolution process, we call it like a convolved map. Okay. So you know that we have two different types of pooling. One is a max pooling, another one is an average pooling. So what happens in a max pooling? Let's say, for example, you got a convolved map, something like this. So when I say max pooling, yeah, I think I should restart my notebook just a minute. Yeah. Let's say, for example, this was a convolved map you got. So when I say max pooling, it basically helps you in extracting important features. So that too, with the max pooling, we have to select maximum element from a grid. You have to select maximum element from selected grid. So what it will do, let's say for example, this is a convol map. Okay, in this you have to extract the important features. So we are going to apply a max pooling. What max pooling will do, this is one grid. So since it's a 4 cross 4 matrix, the grid is getting divided into 4 parts, 2 cross 2. Okay, we are taking 2 cross 2 grid. In that we are picking the maximum element. So what will be the result of your max pooling? What will be the result of your max pooling? See, the maximum element from the first grid is basically 9. Then it's a 7. And then it's an 8. And then it's a 6. So this is how the max pooling is going to work, which basically helps you in extracting the maximum elements. That's it. That's a max pool. That's a max pool. Clear? Understood? Okay. So this is maximum pooling. Next one is we have an average pooling. So when I say average pooling, usually what we do? So we have to find the average of all the elements in a selected grid. In max pool, we select the maximum element when it comes to an average pooling. So we just find the average of all the elements in a grid. Okay, let's say we have a same grid. Same convol map we have in this. You have to select you have to find average value with respect to every grid. So what happens to your average pooling now? What will be the result? Take average of all the elements. 9 plus 2, 11, 11 plus 2, 13, 13 plus 4, 17, 17 by 4. What is 17 by 4? 4 4s are 16. 1 remaining, 4 2s are 8, 4 5s are 20, 4.5. For all the grids, you'll get a same 17 by 4 itself. So the average pooling is 4.25. So this is how the pooling layer is going to work. Hope it's cleared and understood. Clear? This is all about a pooling. After pooling, what happens? After pooling, we just flatten it. So, flatten layer in the sun. So whatever you have in a matrix format, so that will be written in a column format. It becomes like this, one-dimensional array, 1D array. Now this will be sent to the fully connected layer. Will be sending to the fully connected layer. You know what happens in a fully connected layer? Same. You will have an input layer. You have a multiple hidden layers with different neurons. Final output layer. So where the learning, understanding, predictions are going to happen with this. Finally, it just predicts what an image it is. If it's a car image, it sees like a car. If it's a dog, it sees like a dog. Okay, this is how the convolution process is going to work. Hope you got it. Understood? Any questions? So now, a very important concept, an interview question usually people ask, if images 6x6, filter is 3x3 size, what is the size of your convolved map? What is the size of convolved map we got? So it was 4x4, right? Like, how did you get that 4x4? Well, we did it, we got to know that it's a 4x4. But what if I change the question? If I change question to, if image size is 32x32, filter is 3x3, then what is the size of convolved map? Then what is the size of convolved map? So how do you answer this question? How do you answer this question? Yeah. Use a formula n minus f plus 1. How did you get this 4x4? N minus f plus 1. So n was 6, f was 3 plus 1. 6 minus 3, 3, 3 plus 1 is a 4. That's how you got it. Same logic used here. N minus f plus 1. So that tells you what is the size of a convolved map. A tricky interview question, many don't remember. Without formula, you cannot guess this, right? So what is the size of convolved map for this case then? What is the size of convolved map for this case?
30x30.
Yeah. So n is 32 minus 3 plus 1. So 32 minus 3 is 29. 29 plus 1 is 30. So it will be 30x30. Clear? This is without padding. What if there is a padding? With padding, if you're adding extra layers to your image, the formula will differ. So it should be n plus 2p minus f. Okay. So if padding is one layer, image size is 256 cross 256. Filter is 3x3. Then what would be the convolved map? Use this formula. N plus 2p minus f. N plus 2p minus f. N plus 2p minus, not just f, it should be f plus 1. Wait a minute.
It's the same 256 cross 256.
Wait. Just a minute. It's n plus 2p minus f plus 1. Add plus 1. Yeah. So n is 256 plus padding is 1, filter is 3 plus 1. So 3 cancel, so it will be 256. Clear? Understood. So this is how what I can see the convolution process is going to work. All good so far? Everything clear?
Yes, ma'am.
Okay. We'll do the implementation. So switch to a Google Colab. And show you like how you can directly load data into a Google Colab from a Kaggle. No need to download, nothing. Straightforward, you can do things. So today we'll do handwritten digit classification. Okay. So let me stop sharing. Let me reshare. Yeah. So I'm just going to a Kaggle and under dataset section, computer version. So I'm just searching for handwritten digits. Just a minute. Use something else last time to I find that. Okay. So whatever data set, usually when you search and when you select a data, I'm just taking those handwritten digits. So digits are written in handwritten, and based on that, we'll be training our model with these images, and then we'll be what will be passing new image to a model so that it helps us in making predictions. Okay, if you click on a download, basically it helps you in downloading a data set. But I don't want to download. So rather, I want to directly load a data using this Kaggle Hub. So you can just copy this code and you can load your data set. Is chat active to you? It's not available. How do I share a link? You can type another option. Just launch a new Collab notebook. Just use Collab.view. Just launch a new Collab notebook. Heading as handwritten digit. Classification. Yeah. So just import Kaggle Hub and path equals Kaggle Hub dot dataset download. You have to mention this path. It will be available in a Kaggle. Like if you can find this data, you can copy it. Just go to a dataset and search for handwritten digit 0 to 9. If you have Kaggle with you, just go to a Kaggle, go to a dataset and search for handwritten digit 0 to 9. It will show you the first data itself, select it and copy the path. If you click on a download, it gives you entire code. You can just copy that or else type, but you have to type it properly. Do this. Done? Did you type? So we're just importing Kaggle Hub, and from Kaggle Hub dot dataset download, we're just downloading that particular data. No need to download if you have a memory issue. Basically, images will be like very huge, right? So without facing any memory issue, you can just load it from a Kaggle. That's an easiest way. Can you see? It's loaded. Done loading? Shall I proceed?
Yes, ma'am.
Okay. So once you load this data set, you have to see like what are the subdirectories available in it. So we're just using OS. You people know what is an OS, operating system. So just import OS and then OS dot. So let's use a print. Print. I'm calling OS and let me just say list directories of a above path. No S, just list directory. See, these are the different directories. Basically, it's in handwritten digit classification, right? You have numbers or a digits from 0 to 9. That's the reason you have folders, 10 folders, and they have been named like 0, 1, 2, 3, etc. In 0 folder, you have a 0 images. 8 folder, you have all 8 images. 9 folder, you have all 9 handwritten digits. Okay. This is how you see the folders available in it. First step, loading data. So it's handwritten. Digits classification. So first step, load data from Kaggle Hub. Second step, list all subdirectories. Directories in the sense like a folders, subfolders. So what next? So once you list all the directories, the next important thing is you have to display few images. Okay. You have to display few images. So how do you display the images? Because I want to see like how exactly the images are going to look like. First, let's import a libraries. So display, we'll try displaying 5 images in each folder. Okay. Display 5 images in each folder. So how do you display? So I'll be using from, sorry, import matplotlib.pyplot as PLT because I'll be using a subplots. And then we'll be importing PIL in the sense it's a Python image library. So from which I'll be loading image folder. Okay, from PIL, let's import image. That helps you in loading your image. Okay, PIL basically stands for a Python image library. Python image library. Done?
Yes, ma'am.
So now, first I have to define a path. So you know what is the path? So basically, I want to define a base path. So I'll be calling like this is the path, right? To show Kaggle Hub datasets. Okay. Let me try creating a base path. Or just a minute. It is listing. All right. So very first thing, so basically what I do is, I'll just define a subplot. So basically we have a 10 folders. So I'll be calling plt dot a figure of fixed size equals. First, let's set a figure size. So fixed size equals, I'll say like 12, 10. Okay. And then since I'll be running my loop multiple times, I'll start with iteration 1, I equals 1, and then we'll keep incrementing every time so that I can proceed with all the folders. Then I'll just use a for loop. What for loop will do? For loop will loop through your path and it will take each folder. So I'll just call it like the class name. Okay. So I'm taking each folder, that is a subfolder, that's a class name. For class name in, I'm just listing os.list directories of your path. So from this, I'm trying to take every folder name which is available in a original path. See? So I'm taking all the folders. Okay. So once you take all the folders, just for showing you, I'm using a print. So looping through all the folders in a main path, and then you have to create the path for every folder. So how do you create a path for every folder? I'll just call it like a class path. Okay, class path equals, in order to combine your path and your folder name, I'm just using os.path.join. And you have to pass your original path as well as your class name. Okay, if you want to see like what it gives, you can just print a class path so it displays. Can you see? So class name was just a numbers. So we're just adding those class names, that is a folder name. Okay, with the path name, with a path. So that, instead of just our names like 0, 1, 2, 3, we are getting an entire path. Hope you got it. Understood? Okay, once this is done, next thing, I'm removing this. Next, I'll just write a condition that if path exists, okay, if os dot, sorry, if os dot path dot join, oh, sorry, if os dot path dot ease directory, if that particular directory exists, okay, if path exists, so basically what it has to do, so again, we have to create not creating, you just need to tell like how many images you want in each folder. So I'll just call it like if particular directory exists, I'm just calling images equals. So I'm just listing os dot list directory. Now I'm going into each class folder, and from that I'll be extracting five images. I'm just saying :4. So :4 basically gives you 5 images. Hope you are getting. So here looping through all folders. Here adding main path to each folder. Here checking if folder exists. Okay, taking 5 images in each folder. Hope it's clear so far. In image classification and all, like these are the things that you have to deal with. Not much cleaning you have, but this folder creation, path creation, all these things like bit complex. I hope this is done. So now I have to loop through each image, and now we need to create path for every image. See, I'm just looping through for Excel images. If I say for X and images, if I'm trying to print just an X, can you see, you just see the image name 0.jpg, 8.jpg, 7.jpg, right? Again, in order to display these images, we have to combine it with the original path. We have to combine it with a class path. So basically what I do, now I'm going to create an image path. Overall link we wanted for an image. So image path equals, I'll be using os.path dot join. I'll be passing my class path, comma, you have to pass your image. If you don't want X, you can also call it like image. So for every image, so it will be creating a URL. It will be creating a path. Let me show you. So previously this was an image now. So now this image will be like this. Image path will be, can you see? Link as well as at the end, you can see it has been joined with your image name. I mean image file name. Clear? Understood? I'm just removing it, not required. So now for every image, you have to open an image. So I'm just calling image equals. I'll use an image function, which I have loaded. And I'll say image dot open. You have to pass your image path. You have to pass your image path. Then, so that's it, it will open. Now you have to define subplots. PLT dot subplots. How many graphs you want? I want 10 folders are there. In each folder, we want a 5 graphs. So don't you think for 5, it should be like :5? Because 5 is not included. Yeah. So 10, 5. And then you have to tell I, because we are repeating the loop multiple times. We started I equals 1. And in order to show an image, we just use plt.imshow. And I'll be passing an image. And then I'll be giving a title. So plt.title. I'll be passing a class name. Okay, because for every image, basically we want a name of that particular image. And finally, since it's an images, we don't want x-axis or a y-axis. You can just off the axis, plt.axis, you can set it to off. Okay. So finally, since we are using I equals 1 initially, we have to increment every time. So I'm saying I plus equals 1. And then we'll set up plt.tight layout so that no overlapping will happen. plt.tight underscore layout so that no overlapping, and we have to display just the graph. I mean, we have to display just the image. So just call plt.show. Happen subplots. Oh, sorry, it's not a subplot, it's just a subplot. Yeah, make it a subplot. Can you see? Understood? Is it clear?
Yes, ma'am.
You can see all the images, five images. So now VR model should be able to understand all these images. And next, when we pass any new handwritten digit, it should be able to make a prediction. We'll take a break and then we'll continue. Take it till 10:32. Take a break. Oh, sorry, it's 11. The people are back.
Yes, ma'am.
See, like if you understand one project, same way you can do rest of the project. First thing, loading data from a Kaggle Hub. Same for all the data set, whatever classification data set you have, same way you load it. List all the directors, same code, only directors will be different. Displaying 5 images, same code, only our data set might be different. Okay, and then, so now in every folder, I just want to see like how many images we have. Okay, so count the number of images in each folder. Count the number of images in each folder. So I just want to know like how many images we have it in each folder. So how do you find it? Okay, so for this, so what you can do is, if you remember, like we had a class path, right? So this is class path. Mhm. Just a minute. Okay, it was a loop. So again, I have to make use of a loop now. So first, let me list all the directories in original path. Okay, and then let me create a class path for each of them. Class path is going to be os.paddle join. I'll be passing a path as well as your X. So then if I try to print class path, which one? Okay, sorry, yes. So you got all 10 directories. Now you want to find like how many files you have in each folder. So I can just use length, not here. Just use a length. C count equals. Okay, X is basically like a path. So on the C count equals, again, OS dot list directories, and you have to pass each class path. So let me try to print a count. Mhm. We want X as well. I'll say X. Let's do some customization. And then I'll say count. Okay, I'm just using a length. Better use a length. Well, so these many images we have in each folder. I'm looping through all the directories, creating a path for them, and finding length of each path. Okay, finding length of each path, like how many images we have in each folder. So these many images we have in each of them, all like 2000 plus. Understood? Is it clear with the stuff? Next one. Now you have to create a data frame with image and corresponding label. We need an image path as well as a corresponding label. So how do you do it? We need image path as well as corresponding label. So create data frame with image path and labels. Simple. Let me create an empty list in order to store a data. I'll just call it like a df. Okay. And then I'll be looping through for xn os.list directory path. We can debug like this so that it will be easy for you to write a code. Bugging up will not make sense. Okay, you got our labels. Now you need to create a class path for each of them. It's os.path.join. So path and a x. So instead of x, let me call it like a label. Okay. I'm calling like a label. Well, so if you print a class path, okay, we got it. Now again, we have to loop through these class paths. And then basically what we have to do, we have to create an image path, right? So now I'll just say if class path exists, or like you can just say like os dot path dot is directory exist. If this class path exists, so use a for loop. For I'll be taking images, right? For image in os.list directory of your class path. I'm taking each image, and basically what we have to do for every image, we have to create a image path. I'll be calling image path equals os.path.join. You can call your image. You can call your class path and then your image. Okay. So basically what happens for every image, the path will be created. Not created, but I'm calling the wrong variable. So it's an image path. Well, got it. Now what I do, I'll be appending all these into a df. So I'll just call df.append. I'll be appending df.append. What will I append? So I need to append our two values, image path as well as a corresponding label. Okay, so df.append, I'll just append with image path first and then corresponding label. Done. Okay. Next thing, you have to create a data frame. So I'll just call data equals pd.data frame. You have to pass your df. Okay. So pandas is not imported, so please do import pandas. Here. So you can see your data. You got an image as well as a label. So now you can also give a columns. So my column sequence. First column name should be an image path. Second column name should be label. Yes. So this is how you create a data frame which includes image path as well as the labels. Hope you are getting. Do step by step and debug, you will understand it. No need to mug up or no need to remember. Step by step logic. Just do it. Done?
Yes, ma'am.
The next important step, you can see all the images are like together, right? All zeros together, all 5 images together. So how do you shuffle them? You have to mix them up. Okay. So we have to shuffle data so that it gets mixed up. So how to shuffle? Just call your data dot sample and just say fraction equals 1 and just use a random state. Okay. So data equals, I'm just calling data dot sample. Fraction equals 1 is responsible for shuffling. And then random state equals 42. And if you could see your data, you can see everything got mixed up. Can you see? So now even your index has got changed, no? So just reset that. Use reset index so that the index will get reset. This is how the shuffling of data will happen. Shuffling is important, otherwise it becomes biased. Model might learn only related to one specific thing. Hope it's clear. Next one. We have to find height and width of an image. We need to find what is the height, what is the width of an image. How do you find it? Find height and width of an image. When I say height and width of an image, first we have to load a data. I mean, any specific image. So I'll just call image equals data of image path. In that, I'll be taking only one image. Okay. I'm taking first image. And now I just need to open an image. So image equals, you can just call image dot open. And you have to pass your image. Yes, you can just call it like image path. Once you open an image, you just need to use image.size to find the height and width. So height width equals call your image dot size and then try find printing. Image dot open. What's wrong with this? O should be small o. See, height is 90, width is 140. Understood, clear? This is how you find height and width of an image. Any questions? So loading first image from a data frame, opening an image, and then we are just finding the size. Size gives you two things. One is a height, another one is a width of an image. So next important step, we have splitting data. Now you have to split data for training, validation, and testing. So far, if you remember, we used to split data only for a training and testing because we were dealing with a small amount of data that was, usually the data which was present in a table format, different rows and columns. So we were training model with entire data and then we used to test it. But now coming to our images. So we have so many images, almost like 25,000 images you have, right? And the process, how much time it takes. So now, do we need to wait until we train all the images and then do we need to test it? It's like, colleges usually what happens, certain concepts will be taught to you, certain modules will be taught to you, and then immediately they conduct a test. Why do they conduct? So by that, we get to know that how a student is studying, right? What if a college validate you completing all the syllabus, and after completing, if they validate you, if your score is less, and during the time if you say that you didn't understand a concept properly, So nobody can do anything, right? Already you wasted your 3 months. After 3 months, you realize that you didn't understand, you're not doing good. At least in a first test, after completing few chapters, if they conduct a test, they get to know how well teacher has taught, how well you people have understood, and how well you have studied. Getting my point? So same goes here. In machine learning, so it was just like training and testing at the end of a process after training. But here, since so we have so many majors, since we'll be taking more time for training, so we don't wait till it completes learning everything to test it. We test it overall, but still we use a concept called as a validation. So what this validation does, so we will be training deep learning models with images in batches. It's just like the way we teach few chapters and then we give a test to you, same way, validation. So every time we train a model with a batch of images. When I say a single batch, it will have some 32 images. That's one batch. So like that, multiple batches will be there. After every batch, okay. So after learning every batch, the model is evaluated. We call that process as validation. Understood? So right after our training, a batch of images, we just validate a model every time. Let's say, for example, first time you learn something, you will be tested. Let's say if your performance is less, then if we train again with next batch like that, like every time the model performance will try to improve and loss will try to reduce. So we keep a track of that. So that's the reason we use a concept called as training, validation, as well as a testing. Did you understand what is validation? Did you understand what is validation?
Yes, ma'am.
Okay. So basically, we have to split our data for training, testing, and validation. Let's say if I'm taking 70% for training, sorry, 70% will be taken for training, 15% will be taken for validation, and remaining 15% we take it for testing, overall testing. Like after completing training of model with all different batches, we just use a concept of testing. Again, we test and we compare the results. How for every batch of training, like how model performance is increasing, how loss is reducing. We just try to keep a track by plotting a graph. So I'll not finish that if I show it. So anyways, splitting data for training validation, I'll show it in our next class. So once you split them, we do a data cleaning. We don't have much data cleaning in our images. We call it like a image pre-processing. So we'll do basic stuff like bringing all pixels to a same scale, zoom in, zoom out, rotation. So those basic things will be done on our training and testing validation data. So usually we apply pre-processing steps. And then we define CNN model. You know, CNN model in the sense you have to define a different layers, like a convolution layer, pooling layer, and those layers will repeat multiple times. And then finally, fully connected layer. So once we define the model, we'll fit it, and then we'll evaluate the model. And then you can compare, like you can plot a graph to compare the accuracies and also the loss. And finally, I'll show you how you can make a prediction without deployment anything. When you pass new image, like how well it can make up predictions. Okay. So I'll be using two libraries related to deep learning. One is a Keras and TensorFlow, a combination of Keras and TensorFlow will be used. You have one more library, PyTorch. It requires a good knowledge of OOPS. Only then PyTorch can be implemented. But being a beginner, being a student, being an explorer, it's good to go with a Keras and TensorFlow. Okay, so all those remaining stuff we'll do it in our next class. Clear? Understood? So by evening, I'll roll out the project for this week. Probably I'll give it one on clustering. So you can do a project. It will be simple. I guess you people can do projects for this week. One is clustering, one more is image classification. Okay, you decide how you want to split, and accordingly you can submit. So this week, if image, next week I can give NLP related project. Then 2 more weeks I can give a generative AI related. Okay, yeah. All right, thank you. Thanks for joining. We'll catch up tomorrow and we'll do the remaining implementation. Thanks for joining.